And also the combination of the control, you push the control button, you can hide or select O using the center button. So hide or select O, that means the only layer will reveal is the layer you click on. Other layers will be hidden. Okay, let me show you. So I do the hiding O, except the green one. So you see only the green one. Other materials has been hidden. Okay. So this the combination of the mouse, and I push also the control. Okay, on the keyboard. Okay. So when you push the shift, so you will change it into the choose and the menu, and I push auto. Will show you hide and show. So now I hide everything except the green one. Now I will show also the other one to see the relationship between the green one and the purple one. So now I push the auto. It's not useful. Not here. Where is it? Oh, here, okay. So now I push the auto on the keyboard, and also using the mouse left hand button to push on the show, hide or show. So I put if I want to show not only the green one, but also the red one. So I will push the red one. So now you can see red one and the green one, both of them has shown on the screen. Okay, so you can do some practice after you come back home. It's very easy to operate. Yeah. So also the status of the mouse will be showing here. So you don't need to memorize. You just look into the table and to see what kind of operation you are going to use. Okay. Okay. Now I bring everything back. Okay. Okay, that's a basic template. Then basic operations. Actually, I show you several basic operations already. So example, draw a rectangle. So if you want to draw a rectangle, we can push, okay? Select the rectangle, there's a poly one, okay? Then after selection, you go to the structure you want to draw. For example, I want to draw a rectangle. So I need to push rectangle here. So you combine the material and then combine the structure here together. Now you can do the drawing here. Remember, you combine two things together. One, you need to select material, then you need to select structure, then do drawing. Okay? So that's an example, draw a rectangle. So the layout area maxima is quite large. It's around 500 centimeter, I think. It's quite large. But there are limitations for the file size. So if you draw a huge, a lot of things into a huge area, they occupy a lot of memories, so they won't allow it. And also the setup file. Inside the setup files, okay, you can set up the palette. If you don't like the color, you can change the color, but try not to do that so often because the color has been arranged carefully by the vendor. And not only the current color you are seeing, when they overlap with each other, there are some spatial, colors showing when they are overlapping. So if you change the rules, that will change a lot of things. So try not to do this too often, the palette. And application. The current application, I don't see toolbars. So he shows you some information about the toolbars, the location, the layer, icon size, those kind of fundamental setup. the icon size and the location. I think usually we don't do too much change here for the setup, for the application design. Let's see. Okay, so the design, the information showing here, the first one, the importance is about the technology we are currently using. So we are currently using SCNA MEMS, this kind of design technology. This kind of technology, that means when you use this technology for design, the design is following the design rule of this company, this kind of process. There are several different kind of company offering this kind of design criterion, like TSMC. TSMC also has their own design rules. So you want to use in TSMC design rules, the technology part, you need to import the TSMC design rules. But you need to sign contract with them first. Try not to release their secrets, actually. Then you can use the technology. So currently, SCNA is a United States-based company, actually. They offer this kind of structure. So we call technology here. And also, we define the units of the drawing. We call it lambda. Okay. Why not these units as a micron? Why we choose as a lambda? Because we want to make the design more flexible. Because every time, if you finish the design, you draw everything over there. But your teacher tell you, your boss tell you, can you shrink the whole structure 10 times smaller? You need to redraw it again or not? If you define in a fixed number like a micron, you need to redraw it again. But the good thing is that if you design a lambda, you can change the size relatively by changing the relationship between the lambda and the micron. That's the beauty of this kind of design concepts. So we define the internal units as 1,000 lambda. 1 lambda currently equal to 1 microns. So in the future, if you are going to shrink the size by 10 times, okay, you can redefine 1 lambda equal to 100 nanometer. So all things will be shrink automatically. Okay? Yeah, it's very good for IC design especially because after like 10 years, every 10 years, the IC structure seems to reduce 10 times, roughly. Yeah. Okay. So if you don't have this kind of flexibility, the old design you cannot be used for the new, fabrication process. That's a problem. Okay, so that's why we define a spatial called lambda as an intermediate unit. Then define the lambda equal to 1 micron. So the resolution will be here. The internal unit will be 1,000 lambda. That means it's like a 1 nanometer. The internal unit is the resolution. So you can draw the feature smaller than 1 micron. Because the resolution is 1 nanometer, so you can draw smaller features in this configuration. Because the internal unit is 1,000 lambda. Okay, you define the resolution is pretty high. Okay, so the basic things you can see from here is a technology and a grid. And also the grids will be showing here to guide your design. And the grid is not a display always because if you have a very large overview, the grid will become very, very small. You will see all the layouts are considered of the grids. It's not good. So the grids will be displayed like only larger than some kind of a size, and also smaller. The display grid is like a 1 locator unit, and the surprise grid will be larger than 8 pixels. So if you see large areas, you won't see the grids, but when you see the smaller areas, you will see the grids. Okay, and the mouse grid will be grabbed, snapping at a 0.5 locator units. So you want to locate a 0.1 locator units, like 100 nanometers is not possible. You want to do that, you need to change the units here, okay, in order to grab into the correct position. Otherwise, the drawing won't be accurate. Each time you will go to some in the middle steps, okay. So you want to, okay, now you want to see the grids. I just want to magnify the whole structure. To make the structure, you just push the plus, okay, the plus on the keyboard. So now you see the grids, right? So when the grids larger than the size larger than 8 pixels, you start to see the grids. And want to reduce the size of the view, you just push the minus sign on the keyboard. So very easy, plus, minus. So when the image is larger than 8 pixel, I mean the distance larger than 8 pixels, start to see the grids. Okay, now we look into the basic operation number 3. Number 3 has been finished. Number 3 pretty much like this. There is a design. We just look into the design, right? The design part, the setup of design. And okay, setup design, sorry. So see the grids, selection. Drawing. Yeah, those details you can look into the details later on. I just show you the most important part. Okay, now we go to the pen, auto pen. Those are spatial operations I will tell you later on, okay, because they are not necessary to know right now. Okay, now pen, auto pen. So you want to pen left and pen right, just push the directional button on your keyboard. You push the left hand side, you go to left hand side, go to right hand side, go to right hand side, top and the bottom. Okay, push on the directional button. 那个方向键, okay. You can pen up and pen right, okay. And zoom. Zoom just using the plus and the minus, okay. You plus, you minus. Zoom in, zoom out. And the home. If you push the home, you will come back to the origin here, okay. For example, if you pen far away, you push home, you will come back to original position. That's a home. And okay, the drawing tools arrow. Okay, the drawing tools already just give you some ideas about the rectangle, Manhattan structures, and also some kind of triangle structure, circular structure things. So you can try to use them, okay, as you need. Those are the basic operation, and okay, select option that you're hiding. Okay, I just show you all the operation about the drawing, and also how to hide, how to review the layers you want to see. And you also can move, okay, for example, the structure to the different position. First select the structure, then try to move using the center button. And also you can do cutting, okay. So the cutting, you want to cut one piece into 2. You can go to the edit. There's a function we call the cut. So once you push the cut, what's going on? Disappear, okay. Oh, okay. You can paste. Okay, he's come back. You can cut, copy. So you can cut, copy, rotation. You can duplicate, okay. So you want to, after you finish one drawing, you want to duplicate it, you just push duplicate. So all can be duplicated into many pieces. And also status merge, okay. Duplicate, select all, find. Spatial extract. 0 here, okay. Yeah, can move, rotate. Okay, rotate is here. So try to select this one. And in the draw, you can do rotate. And can slice. Slice means you can cut into different pieces. So we can slice horizontally or vertically. So we try the horizontal slice first. So it will show you a line here. So put your line into the position you want, and then you will cut it into 2 pieces. Okay, it's called a slice. Slice, merge. Okay, also after we select these 2, we merge them into 1. Okay, so you can freely to merge different structure together. For example, this one, and then we want to do extension selection. So now we select 2. So we want to merge these 2 structures. After we select these 2, we do the merge action. Do they merge? No, they are not different. They are different layers, so they cannot be merged. Okay, let's try a different one. Okay. Okay, try to merge these 2. Yeah, they are merged. See? So on the same material, you can do the merge. Different material cannot do merge. Okay? And some other things. Merge. Yeah, flip. Yeah, this is some simple operation. Memory monitor. Okay, status memory monitor. And the save file. Okay, you can save your file here. To save it into different name. Save as. So this is like a similar to your word operation. Okay, in addition to this, I want to give you some view of the spatial operation. For example, currently we have a cell 0, right? So you want to do different cell operation. You can open new cells. For example, we give a new cells, give it a name cell 1. You can get different name. For example, like NMOS, CMOS. Currently we give a name called cell 1. Okay. Then we have another cells called cell 1. So now I draw something in a cell 1. After finish this one, I come back to cell 0. So we can open cell 0. So now it's cell 0. We have 2 cell 0, so cost 1. Okay, use the other one. Okay, now we want to import the cell 1 structure into this one. Okay, so we can use instance. So instance cell 1 structure as a whole into here. So now you see the cell 1 over here. So now you can select cell 1. Too many things. Let's remove all those things. Okay, this is cell 1. Okay, this is called cell 1. Okay, so you want to repeat cell 1, you can just duplicate. Okay, once you want to duplicate this for 1,000 times, you got 1,000 similar, exactly the same things over there. So the good thing is, once you want to change the interior structures, all 1,000 pieces will be changed at once. Okay, so you don't need to change them one by one. Okay, you just need to go back to the cell 1 to change. For example, so now want to change the center, the size of the center one. So we come back to the cell 1 and change the size. Select this and try to move edge to make it smaller. Okay, smaller. So you now you go back to this one. So all these structures being changed at once. You don't need to do it then one by one. So that's why it's important to do the design in hierarchical orders. You build up simpler components for different cell name under different cell name. So for the same cell, you import them together. You make it as an array. So once you want to change the structure inside the cell, so you can do it in a specific cells. Then all the cells imported into your final layout will be changed at once. Okay, so this can save you a lot of time on the design. It's important. So don't try to put everything onto only one layer flat. It's not good. Okay, try to make them hierarchical orders. Okay, for similar structure using one cells and then import them, arrange them together. That's one thing. Okay, the other things, interesting things I can show you is you want to see spatial DRC, design rule check. Design rule checker is only for IC because you are using technology, competitor technology. Is a SCN MEMS. So yeah, maybe they can accept some MEMS design, but usually they'll combine with some IC or IC rules. So design rule checker is under rules. So you put the design rule, you push the maybe we go here first, okay. Then try to use in the design rule checker, DRC. Okay, so if there are something wrong, they will show you some bugs. Hold on a second. Press arrow pose. Okay, here. So he shows there are 3 design rules violating. Let's do this again. DRC. Okay. Okay, it shows you 3 DRC errors found. So the 3 DRC error found here. So you can click each individual one to see what's going on. He will show you what's the rule you violated. So you need to correct the size or correct the relationship until there's no error showing. But it's for IC design. But for MEMS design, you will violate a lot of rules. So it's okay. So I encourage you to do the IC design first. Make sure the IC design part, there's no problem inside. Then put down your MEMS structure later. So after you put down the MEMS structure, there will be some error. If the error is you look into is okay, so you just ignore the design rule checker for your MEMS part. But currently it's showing 3 errors. It's quite easy. If you don't do it correctly, you sometimes will see like more than hundreds of errors. So you will do the correction one by one. It's the one thing you can use for your IC. The other one is the cross section is also important, useful. So when you push the cross section, give cross section name. Go into here, okay. Okay, so now you see we see the cross section in this area. You can see only one layer has been cut through. There's a red layer. So others are empty here. So let's do it again. The cross section view. I want to change the position. Okay, we can see different place. So by select the position here, so now it's 18 pixels, so we can move a little bit above. So you can see two layers here. So one is the metal is the blue one, the other is the red one. So you can see the red one is on the bottom of the blue one, but there are no connection here, right? So you want to do connection, you need to put some metal, I think it's a metal contact, let's see, poly contact, poly 2, active. It's metal contact, view, using active contact. So draw active contact here. Not here. Okay, now we see it again. It's not, still not. Section. Still not showing here. Okay, if you put some view, some contact hole here, there should some contact showing here, but it's not working now. But it's okay. We can come back home to try to practice to understand. Yeah. So those are spatial functions for you to understand. And so after you finish the layout and also correct all the errors, and you come back to your final things, you can do you can send out the layout design to the vendor. The vendor will do the mask design, mask verification layer by layer according to your drawing here. Okay. So this just show you one of the example. So the other example is I just show you is this one. Okay, the fan structure. So in the fan structure, actually, we have different cell layers. So when you open the cells, we can see we have NMOS, PAT, and the PMOS. So NMOS, this is a circuit. Okay, and we open the other one, PMOS. Is a larger one, okay. And we open the final layer. We call it a fan. The fan will combine NMOS, PMOS, bonding pad. So it's not fully finished yet. So want to control this one, we will connect the fan and also the NMOS, PMOS together. That will be in your homework one, the next homework. Okay, don't worry. After the midterm one, you will get the homework. Okay, not now. Currently, just focus on your midterm one. Okay, so in the homework, next homework, you will design the size of the NMOS and the PMOS in order to provide a large enough of the current to drive your mixer or sensor. Depends. Okay, in the homework is the sensor. Okay, you need to have enough current to drive the sensor. So you will calculate this drawing just follow the design rule. So that when you do the design rule checker, there's no error at all. Okay, it is easy to get a lot of errors. So I will send this file to you as your foundation, so you can change the size from this kind of drawing. And because this is size quite small, so the current, the drive current is quite small. So if you want to drive a larger system like this, you need to extend the length about like maybe 100 times, 10 times to 100 times. Okay, so you will make them compatible and put them together, become the final layout. So the final layout, you send the final layout to the vendor. Vendor can slice them into different layers for mass fabrication. So you can use it as mass for final fabrication. So this just give an example. Okay. Yeah, so in this example, I already drew the NMOS, PMOS for your easy use in the future. Okay, So maybe you can use this as consider as an example, yeah, for the future design. Okay, I think pretty much we have talked almost about all the fundamental things here. Yeah, I think that's it. So there's a book regarding the CMOS layout design using LEdit. So if you have this book, that will be easy to follow and also to come back to have some review. And if you don't have the book, it's also okay. I think you just follow my instruction here, and also some very simple ideas about the operation, and do the practice by yourself. Okay. Yeah. So the software I will ask a TA to send it to you. So the student version, so you can set up into a computer easily. But remember, if your computer is too fancy, too advanced, it's like using Windows 10 something, there will be some problem. Okay, currently we are using Windows XP or something. I don't know. 7 or something, Windows 7? Yeah, I don't know your computer is more advanced or not. So I haven't tried this in Windows 8 or Windows 9, so you may try, yeah. But for Windows 7 it's okay, it's working. It's workable, okay. Okay, yeah, so just give you some fundamental things. So hope you enjoy it later on. Yeah, so any question regarding today's lecture? I think it's simple, just some operation. Okay, if you know, we stop our lecture here and see you next week for the midterm.